Alright, I'm going to show you about capacitors today. I have a circuit shown on here that will show you everything that's going on in the circuit all at one time. I have a variable power supply. I have two switches. I have a multimeter hooked up here to show me the voltage across the capacitor. That right there is the CPO super cap. It's got actual capacitors inside of it. This will show us the current in the circuit, and this right here is a light bulb to show us if there's any current going through that light bulb. So let's see if I can get this where you can read it better. Alright, I think we can get both. There we go. So I'm going to throw the first switch. First I'm going to do that and get rid of all the voltage on the capacitor. You saw it went down to 0. I throw this light switch. Notice the light comes on. The current is going down, but the voltage is going up. And you should notice that the light is just about gone. Okay, again, the voltage is going up. Sorry, the voltage is going up, and the current is going down. Now, why is that? Because as the capacitor is filling up with electrons, as the electrons are being pushed into the capacitor, it's getting full. And once it's full, it has full voltage, but it can't store any more charge, so that the current actually drops down to 0. We'll give it another second here to fill up. Again, notice the current going down. At this point, the light bulb is so dim you can't see it. Alright, notice that's pretty close. We're supposed to be at 1.5 volts, and we're pretty close to 1.5 volts up there. It'll actually take a while for it to get all the way up to 1.5 volts, and this is quickly going down to 0. Again, if we took another 30-40 seconds, that would go all the way to 0. So instead, I'm going to disconnect this one. Okay, so notice I still have my voltage. It's going down slowly. Why? Because the multimeter, the voltmeter, is actually reading that, so it's slowly using up the voltage. But the current went down to 0. But now I'm going to discharge the capacitor, and watch this light and so forth. Okay, the light came on, the voltmeter is going down, the current meter is now reading negative. That's pretty important. So why is the current meter, or the ammeter, reading negative? Because current is flowing off of the capacitor. And again, notice the voltage is almost gone, and the current is going down very quickly. Now if I discharge the capacitor, watch how fast that current goes. Gone. I just discharged it very, very quickly. Now I'm going to up the voltage just a little bit. I was on 1.5. Let's go up to 3. Hopefully I won't cause any issues with my multimeter. Now let me charge. Ready? Okay, light bulb. Oops, sorry, let's do that again. There, light bulb's on. Notice the current is going down, the voltage is going up. The light bulb will eventually get dimmer because the capacitor is filling up. And another way to think about this is if you have a closet, it's easy to put stuff in the closet when it's empty, but once the closet gets full, you can't get any more stuff into it. You'd have to push harder and harder, and eventually you just can't put any more in. Now that voltage should go up around 2.2 it says on the battery eliminator, and the current is slowly going down. And notice the light bulb is just about out because the capacitor is just about filled to capacitance, or to capacity. And the current will go down, and the last little bit of voltage will take a while to reach. So let me go ahead and disconnect that. Notice the current again is positive. Okay, notice the voltage is going down slowly. I discharge the capacitor, and notice the current is negative, meaning the current is flowing off of the capacitor. It charges one way and comes off the other. Think about pushing water into a water tower, and now we're letting the water drain out of the water tower. And notice the light again decreases now. Why was it on bright as soon as I started to discharge? Because the capacitor was full. It's like opening up your closet again. You open up a full closet, at first you get a rush of stuff coming out, a rush of current, but once most of the stuff is gone, then all of a sudden there's no current left. So notice as the current goes down, there's not enough current going through the light to light it up. And this will go down to 0. Notice, for a discharged capacitor, let's just discharge it. Okay, the voltage of a discharged capacitor is always 0. And the current, there's no current coming off of it as well. We're going to do something else here in a second.